Good day. Today we are going to go over area and most importantly area of complex rectangles or compound rectangles, because that's a little bit harder to calculate and to know what to do there when you look at them. But to review about area first, remember the area, since we're talking about rectangles, area of a rectangle, we calculate that by doing length times width, and that will give you your area. This is the formula for finding area of a rectangle. It's called a formula. All right, so if you have a rectangle here and it is 3 units this way and 5 units this way. I say units because it doesn't matter if it's inches, feet, centimeters, miles, whatever your units are, it still works the same way. So if it's 3 this way and 5 this way, you'll plug those in. Some people think of length as going this way and width as being this way. Okay, or you can just pick whichever one is the longest for your length. Just as long as you take both of them and you multiply them together, that'll give you your area, because this would still be the same rectangle if we turned it this way, right? Okay, so 5 times 3 equals 15. So this rectangle is 15 units squared for a rectangle. Now, why do we call it squared? Let's say these were inches. 3 inches and 5 inches. Why would we call that units squared? It would be inches squared. Well, to do that, let's look at a grid. I have some grid paper here and a sheet protector, because remember I told you that's a nice way to be able to print something out and use a dry erase marker on it. So let's take this same rectangle we were just using. So 3 by 5. These aren't quite inches, but we'll pretend that they are. Okay, so this is 3 by 5. What are these in our grid? They're squares, right? So when we're talking about our units, again, let's say these are inches, okay? 3 inches times 5 inches is 15 inches squared. Or you can say 15 square, it's usually abbreviated, inches. Okay, 15 square inches. What they're saying is there are 15 little 1-inch squares in this rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Did I count that wrong? 2, 3, 4, 5, 6, 7, 8, 9. I forgot those. 10, 11, 12, 13, 14, 15. All right, so there's 15 of these little squares in here. All right, so that's our review of how area works. So when we're looking at compound rectangles, remember a compound word is when you have 2 words put together to make a new word. Compound rectangles take 2 rectangles and they put them together to make a new shape. So let's say we have this rectangle here and this rectangle here. When we put them together to make a new shape, we're going to take this line away because it's all one shape now. Okay? So if you saw this and they said, find the area, what would you do? There's actually a few different ways you can attack this problem. You can solve it. So you can either think of it as the way that we had drawn it. Remember, there was this line right here. Okay, So you could think of it that way, and you'd find the area of this one and the area of this one. Or you could divide it up right here and do this area and this area. Or you could even imagine this as being complete and find the area of the whole thing and take those away at the end. We'll do one like that later. But for now, let's do it this way. Okay, so this is 1, 2, 3, 4, 5. 1, 2, 3, 4. And then this right here is 2 and 3. All right, so you're probably thinking, well, hey, why don't I just count up the squares inside? If you have the squares, go ahead and just count them up. That's the easy way. But what if they gave it to you without the paper or without the grid, right? What if it was just drawn on your test like this? So let's find the area. Push that back in all the way. Okay, find the area of this rectangle. You do length times width, 5 times 4. That's 20. Now let's find the area of this small rectangle. It's 2 by 3. So 2 times 3 is 6. So the area of the whole thing all together, remember all together is one of those words that tells you need to add. So all together, this compound rectangle is 26. We'll say inches squared again, or centimeters squared, or feet squared, whatever it tells you. If it doesn't tell you what the units are, just leave them off. It's better just to leave them off instead of to guess what they meant. Okay. How about oh, my marker made a squeak and my dogs did not like it apparently. It was a marker. Okay, so look at this crazy one. So again, you can divide it up different ways. You just have to see where you can cut this apart. So we could cut this here. We could either chop this part off the top or cut it here. Let's cut it right here. Okay. So that's where we're going to divide this shape up to make the different sized boxes. Now, if you notice, this is a square. And squares are kinds of rectangles. They're just the special ones. Okay. So 1, 2, 3. This is 4 this way. Now, if you have a problem like this, they would probably give you this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is all 11. And then they tell you that this is 2. This is 2. And they would probably tell you that this is 2 and 1, 2. This is 4. Okay. So, I take that back. If they told you that was 2, we'd probably want to cut it right here, right? So let's say this is 4. Okay, so let's think about this right here. This one, we don't know yet how long this rectangle is that we cut off right here. So we're going to have to figure that out, aren't we? This one, we don't quite know yet how tall it is. I mean, we've got the boxes to count, yes, but pretend they're not there. Okay, this one we know both sides, so 2 times 2, that's 4. How are we going to figure out how tall this is? Well, it's this tall, and plus it's this tall. Well, how tall was this? This little box, this square, was too tall. So if this is 4 and this is 2, that means the whole thing is 6, right? So it's 4 times 6. That'd be 24. Okay, now let's figure out how long this is. So the whole thing is 11. This much is 2. This much is 4. So how much is left, right? That's 6 so far. If it's 11 total and this is 6 so far, that means that this is 5, right? Because 5 plus 4 plus 2 all makes that 11, right? So this is 4 by 5. 4 times 5 is 20. All right, then we want to add these all up to get the area of the compound rectangle. So we'll do our 20 plus our 24 plus our 4. And if it's easier for you, you can just write them vertically like this. Eight, 4. So our whole area is 48. Okay. Now let's do one of those ones where we take away. So let's have a rectangle like this. But instead of it being complete, we're going to have a chunk missing out of it. All right, so we can do this like the other ones, where we chop off a piece there or here and we add them together. Or, like I said earlier, you can think of this as being a whole rectangle. All right, so if this rectangle was complete, what would its area be? Let's see, it was 1, 2, 3, 4, 5, 6, 7 tall, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 long. Okay, so find your area. What's 11 times 7? Remember your 11ths trick, you'll just double this digit. The area of the whole thing is 77. Okay, but that's including this part. We want to cut that part out. Remember, when you're cutting it out, you are taking it away. That means you will subtract. So how much are we going to subtract? How much will we take away? This is 3 by 4. 3 times 4, the area of this section is 12. We're going to take away 12. And that will give you the area of this blue part, right? Let me do this over here. 77 minus 12. 65. The whole thing would have been 77, but we were missing 12 square units. So we're left with just 65. All right, so I hope that helps you figure out how to work these kinds of problems. These problems are very common on tests, especially standardized tests. You'll even see things like this in high school on the ACT. Because they're really good to display your problem-solving skills. If you have any questions, ask in the comments, and I'll give you guys a worksheet if you want to practice it. Have a good day.